Welcome to the show. Today, we're diving deep into the icy waters of our polar regions, where change isn't just in the air, it's in the water itself. Global warming is causing a significant decline in sea ice. This isn't just about melting ice. It's profoundly altering the very light that enters the ocean, with big consequences for marine life. You see, sea ice and open seawater treat light very differently. Under sea ice, life has adapted to a dim, but surprisingly multicolored world. The ice scatters sunlight, allowing a broad range of visible wavelengths to penetrate. Think of it as a soft, filtered, rainbow-like glow. But when that ice melts away, the ocean turns blue. Liquid seawater is a natural filter, rapidly absorbing red and green light, letting the blue wavelengths travel much deeper. Why the difference? It's down to water molecules. In liquid water, they vibrate freely, creating absorption bands that chop out parts of the light spectrum. In ice, these vibrations are suppressed, so more colors get through. So, as ice disappears, the underwater light shifts from this broad spectrum to a blue-dominated one. This is a huge deal for tiny photosynthetic organisms like ice algae and phytoplankton, the base of the polar food web. Their photosynthetic pigments are tuned to that diverse, multicolored light under the ice. Suddenly, they're in an environment where the light doesn't match their tools. This spectral shift can hit their photosynthetic performance hard and is expected to change who thrives. Algae species good at using blue light might take over. In fact, in some Antarctic coastal waters, we're already seeing an increase in cryptophytes, which love blue light, while pigment-rich species adapted to under ice conditions are declining. These aren't minor tweaks. These algae are the powerhouses of polar ecosystems. Changes in their productivity or species mix can ripple up, affecting fish, seabirds, and marine mammals. And let's not forget, ocean photosynthesis is a key player in soaking up atmospheric CO2. The thinning ice also means longer open water periods. More light, for longer. Sounds like a boost for life, right? Well, it's complex. Increased particles from melting glaciers or land runoff, and even more clouds, can limit light penetration, especially near coasts. In some areas, even with more sunlight hitting the surface, the water has become less transparent as phytoplankton and sediments quickly absorb the light, stopping it from reaching deeper. So, any production boost isn't guaranteed everywhere. The timing of ice melt and freeze up is also crucial, affecting the timing and strength of phytoplankton blooms. Beyond light, less sea ice disrupts zooplankton's daily vertical migration patterns driven by light. This could mean food shortages for them and the creatures that eat them. And of course, species like certain seals and walruses are losing vital habitat for breeding and raising their young. In essence, the loss of sea ice is triggering a cascade of changes. The increased light, and especially that critical shift in its color, is fundamentally restructuring the base of the polar marine food web. It's a stark reminder of how interconnected our climate and ecosystems truly are, posing serious challenges to the delicate balance of life at our poles.